Hi everyone, so today we're going to take some time and review how to solve multi-step equations. Today we're going to focus on the basics of multi-step equations as well as distributive property and solving multi-step equations with fractions. On this first problem, we're going to review how to solve multi-step equations by comparing and contrasting these two problems. So you can see that we have the same exact terms, except on the first problem, the equal sign is in between the 9 and the 6x. And on our second problem, the equal sign is in between the 6x and the 27. So in our first problem, okay, and I always like drawing the line in between so it separates the two sides. Because the 3x and the 6x are on different sides, okay, we have to move the variable over so it's only on one side to solve. So, and in order to move it, we have to do its opposite. So we're going to subtract. Our first step would be to subtract the 3x over on both sides. And remember, the golden rule of algebra is whatever you do to one side, you do to the other side. And the reason I move the 3x instead of the 6x, it'll allow me to keep the x as with a positive coefficient, so I don't have to worry about negative coefficients. So that, and the reason we do that is we take away 3x from both sides, because what you do to one side you do the same, and then you'll have 0 x's left on the left side, and all you have left is 9 on the right side. And then you make 3 0 pairs, okay, and you would have 3x left on the right side, and then you would leave the 27 alone because you can't combine like terms. Then what we have to do is we have to isolate x. So what's in our way of x to get x by itself? The 3 and the 27. So how can I get rid of the 27? I need a 0 pair it out. So if there's 27 positives, how can I make it a 0 pair? Okay, so I subtract 27, but what I do to one side, I have to do to the other side. So that means I have 3x left on the right side because the positive and negative 27 0 pair out. And then I have a positive 9 and a negative 27, which means there are 9 0 pairs, which means I have negative 18 left over. My final step is divide everything by 3 to get x by itself, because 3 is being multiplied by x and the opposite of multiplying is dividing. So x equals negative 6. Okay. And so on our next problem, I'm going to draw my line in between the 6x and the 27. You can already see there's an imbalance compared to the other one, right? There's only 27 on the right side. Okay. So instead of moving, because 3x and 6x are on the same side, we're going to combine like terms. So if you have 3x's and then 6x's, how many x's do you have in total because they're on the same side? So then you have 9x's total, plus 9 equals 27, right? While our numbers are different, okay, the same idea happens. So we have to isolate the variable. So we have to get the variable by itself. So you have these 9 positives. So how do I make these 9 positives into a 0 pair to get rid of them? Because that's our goal, to isolate, to get x by itself. So to make a 0 pair, you have to subtract 9. But what we do to one side, we have to do the other. So then we have 9x equals 18. So you can see on the other problem we had 3x, but this time we have 9x. And then, but you're still going to do the same thing because you have to divide by 9. And so x equals 2. Okay? So just by moving the location of the equal sign, okay, the answers change quite differently. One's a negative 6 and one's a positive 2. So pause the video, take a minute, and explain in writing how you went about solving these problems differently and why. Okay. So in this first problem, our first step, right, was to subtract 3x from both sides, right, to isolate, to get the variable on one side, to isolate the variable on one side. Then once we did that, right, we subtracted 27 on both sides to get that the x by itself. That was our starting process, right? Then step 3, divide by 3 on both sides to get x by itself. Okay? Whereas on this problem, our first step was to combine like terms. And then, which meant we added 3x and 6x, right? And then we subtracted 9, both sides, to start getting x by itself. So you subtract, okay, the the constant to make a zero pair. Then our third step was to divide by 9 on both sides to get x by itself, to solve for x. So you can see similarities and differences between the steps. Okay, so in this next problem, we have distributive property on both sides. So our first step would be to distribute everything, the number on the outside of the parentheses, to everything on the inside. Okay? So 3 times 2x is 6x minus 12 equals 8x plus 16. Right, so our first step was to distribute the 3 and the 2. And now our problem looks exactly like it was on the previous problem, right? So I have variables on both sides. Because I have variables on both sides, I have to get rid of one of them. Okay? So I'm going to get rid of the 6. So I'm going to subtract 6 on both sides. So what I do to one side, I have to do the other. And what that allows me to have is I bring down the negative 12 because I didn't do anything with it. The 8x minus 6x becomes 2x. And then I didn't do anything with the 16. Now I have to get rid of the 16 because I want to get x by itself. So I'm going to subtract 16 to make it a zero pair to isolate the variable. So now I have 2x. I don't do anything with 2x. That's positive 16, negative 16 becomes 0. Then I have a negative 12 and a negative 16. So none of those zero pair out. So what I have left is negative 28. Then my last step is to divide everything by 2. So then x equals negative 14. Okay. And I want to make sure I'm checking my answers because you can see if you're right. So you always check with the original problem. So my original problem is 3 times 2. And wherever this x is, that's where I'm going to put the negative 14 times negative 14 minus 4, right, equals, run out of room a little bit, 2 times 4 times negative 14 plus 8. Okay, order of operations says we have to do everything inside the parentheses first. I'm going to leave the 3 alone. I have to multiply my 2 and negative 14, which gets negative 28 minus 4. And you always want to do one step at a time to make sure you're not making simple mathematical mistakes. So 4 times negative 14 is negative 56 plus 8. Okay. And so negative 28 plus minus 4 is negative 32 times 3, because I didn't do anything with that 3, times negative 2. No, positive 2. I don't know where the negative came from. I apologize. I think that was just and the negative 56 plus 8 is negative 48. So 3 times negative 32 is negative 96. And you're looking for the answers to be the same. So 2 times negative 48 is also negative 96. So if the two numbers equal each other, you know your answer is right. So for this problem, we know our answer is negative 14. Okay. So how does this problem change from the previous problem? Okay. So you can see on this problem, I added a negative 10 x to the left side, then the 2 became a negative. Okay. So the difference between this problem and the previous problem on the first step is because the negative 10x or minus 10x is not within the parenthesis, you leave it absolutely alone and you just multiply in the 3 to the 2x and the minus 4 and the negative 2 to the negative 4x and the 8. Okay. If you feel confident about this problem, you want to try it by yourself, or you just want to try it by yourself, pause the video and try it, and then come back and watch, and you'll see how I will go about solving the problem. Okay. So I want to give myself some more room so you guys can see on my work. So 3 times 2 is 6x minus 12 minus 10x equals negative 8x. It becomes a negative because you're multiplying negative 2 times a positive 4x, then negative 2 times a positive 8, which would be negative 16. And draw my line in the middle because it's easier for me to see. So because I have 6x and a negative 10x on the same side, I will combine like terms. And what I see is that because you have positive and negatives, you can zero pair things out. So when I zero pair things out, I have more negatives. So that means I have negative 4x left. So let me change colors for you so it's a little bit easier to see what I'm doing. So I have a negative 4x. And then everything else I'm going to rewrite exactly as is. Because I only use these two terms, everything else is written exactly the same. So negative 4x minus 12 equals negative 8x minus 16. Now I go back and solve it exactly like I did in my previous problem, just with these different numbers. Because this is a negative 8x, when I zero pair it out, I'm going to add 8x to both sides. I'm going to do that because then it'll allow me to have positive x's. And that I like that because then I don't have to worry about multiplying or dividing at the end with a negative number. And sometimes we forget about the negatives. Okay. So 8x and a negative 4x make 4x. I didn't do anything with a negative 12 again, so I'm going to leave it. Equals negative 16 because my positive and negative 8x cancel out. My next step is to add 12 to both sides. So then I have 4x equals negative 4. Then I divide by 4. And then x equals negative 1. Okay. And then remember, when we check, we always check in our original problem. So in our original problem, we have 3 times 2, and our answer is negative 1. So times negative 1 minus 4 minus 10 times negative 1 equals negative 2 times 4 times negative 1 plus 8. Okay? Looks like a lot, but just take one step at a time. Okay, I'm not doing anything with the 3. And then 2 times negative 1 is just negative 2. And I don't do anything with the negative 4, so I just leave it there. I can multiply my negative 10 and negative 1, which becomes a plus 10. And that's going to equal, I don't do anything with the negative 2. 4 times negative 1 is negative 4 plus 8. So then I have to simplify inside the parenthesis even more. So I keep on leaving the 3 alone. Negative 2 and a negative 4 make negative 6. I don't do anything with the plus 10 yet. Equal to negative 2. Negative 4 and 8 plus 8 makes 4. So I'm going to finish off this left side or right side just because it's just negative 2 times negative 4, which is negative 8. Because it's on the other side of the equal sign, I can finish it first because it doesn't matter on the left side. And then I can finish off the left side. 3 times negative 6, negative 18 plus 10. I can make 10 zero pairs. So negative 8 equals negative 8. So I can see that it works out. So my final answer I know for this is x equals negative 1. Notice how I box in only the x equals negative 1 because that is my final answer. So we're now going to move on to fractions. Okay? And we want you guys to compare and contrast these two problems differently. While they are all the same numbers, you can see that the difference between the two problems, right, is the division of 3 is over both x and 4, whereas this one, the division of 3 is only under the x. So remember when we learned how to deal with multi-step equations with fractions, we actually learned how to fraction blast them and just get rid of them completely. So what's my common denominator? In both of them, they happen to be 3. So I'm going to multiply everything by 3. In this first problem, there's only 2 terms. This, the x plus 4 over 3, and the 5. So remember, what happens when we multiply the 3 times x plus 4 over 3, and then 3 times 5 is 15, those cancel out. So what ends up happening is you just have x plus 4 equals 15. Okay? So then you just subtract 4 on both sides, then x equals 11 for this problem. Whereas on this right problem, you have 3 terms. So what happens on this problem, it ends up being 3x over 3 plus 12 equals 15. And then these cancel out. So you have x plus 12 equals 15 minus 12 minus 12, x equals 3. Okay. Just take a minute, explain how these problems are different, and we'll move on to our final problem for the day. So what happens when you have fractions that aren't common denominators, right? We have a 2 as a denominator and a 4. Well, you have to find the common multiple, okay? Least common multiple. So in this case, the least common multiple is 4. So we're going to take 4 and multiply everything. But we can't multiply a fraction with a whole number. So you have 4 over 1 times 1/2 equals 4 over 1 times 3x over 4 plus 4 times 3 minus 4 times 2x. Okay, so what ends up happening is you have 4 over 2 equals 12x over 4 plus 12 minus 8x. So in the previous problem, you saw me cross cancel, and I was able to cross cancel. I showed you the step of how to cross cancel. You actually multiply the numerators with the numerators and denominators with the denominator. So you end up getting 2 equals 4 goes in 12, 3x plus 5 plus, I don't know where 5 came from, 12 minus 8x. Okay. So now that I'm moving things to both sides, I add my line. So because I have a 3 and a negative 8x on both sides, I can zero pair 3 x's out because I'm going to combine like terms. So I have a 2, I leave the 2 by itself, and then I end up having negative 5 x's left plus 12. Okay, and then I can subtract 12 from both sides because my goal is to isolate the variable, and then so that would zero pair those out, and then I have negative 10 equals negative 5x, divide both sides by negative 5, and x equals 2. Okay, so that's how you would go about solving with fractions. So hopefully this was a great review on how to solve multi-step equations with distributive property, with fractions, at variables with both sides, combining like terms. Okay. If you have any questions, make sure you email me, and hope to have a great day. Bye.